Hello guys, welcome back. Today I'm going to be going over a little bit about how I programmed these circuits. As you can see right here, I have a couple of them working. I'm just going to go over how I programmed each of the gates and how I programmed the wires that connect them together. So to start off, just with a little bit of how I organized it, I created this gate parent class, and then I had every other gate inherit off of it. So if you see right here, it says parent class is the gate parent. So basically all that's saying is that any functionality that I programmed into this class also goes to my inherited classes. So like this long line of code right here goes, even though you don't see it in the event graph, this is just completely empty, it still has the functionality. So let's start off with the gate parent real quick. I'm just going to go over all the variables that can be found here. So these first three we see are material instances. And so all that means, when we look here in the construction script, is we're creating dynamic materials. And all that is it allows me to switch the material of my output or of my gates and my connectors or wires, whatever you want to call them, so that they can change between on and off. So if we look right here, we can see that my voltage off material is blue and my voltage on material is red. This is completely arbitrary and just something I chose because I thought it would be easy to visually see as I'm trying to practice with these circuits to get them to work. And so we're just, for each of our outputs, or for our output and each of our inputs, we're just setting up the material so we can turn them on and off whenever we want. So in these next two variables, let me get back to the event graph, we have input 1 on and input 2 on. So these are just booleans that are either true when input is actually on or false when input is not on. And so we're going to feed these into our gate test right here, and that will determine whether or not our output is actually on or off. So then this was on boolean right here. I'm going to talk about that a little bit later, but essentially all it's doing is determining if the output is actually changing or not. So then I have three arrays. So our output gates is just any gate that this current gate is connected to. And so we have to remember we're talking about gate instances. So there is no particular gate. This variable will have a different value for every gate on or in our circuits. And then the input for the gates is just a boolean where I set it, if the boolean is true, it means that the output of our current gate is going to input 1 of the next gate, and false if it's going to input 2, which we'll see here a little bit later, but it's just determining, and I'll walk us through that in a second. Lastly, we have this output connector, and this is just an array of every wire that is connected to our output so that we know what our output is affecting. So let's just walk through how I programmed this long line of code. So we start off with 4 events right here, which are turn input 1 on, turn input 1 off, and the exact same for input 2. Then depending on which event happens, we are setting the material to on or off. Like I said before, for turning it on, we have our voltage on material. Turning it off, we have our voltage off material. Then this right here is setting our input 1 on and input 2 on variables, so that then when we go to the gate test, we have the variables set so that we can actually determine what the output is. And I should say that by default they are set to false. This event begin play is just something that happens whenever the game starts up, and it's just to let my gates kind of start working together at the very beginning. And for most gates, they will probably evaluate to false because both of the inputs will be false. But some of them, like a NAND gate, for instance, where any one or more gates or inputs that are off causes the gate to have an on output, will actually turn on and will cause other gates to turn on in effect. So just a little nuance there that I was trying to control. So then once we determine what our output is here, we go here, we pass that to a branch, which if our output is on, which is true, then we will go up to this top branch. If it is false, we will go down to the bottom. So here's that was on variable that I mentioned earlier. And we can see that we're passing it into branches as well, which this is a little weird. So we're taking, if our branch is on, so if our output is on, we're passing it into this branch, but then we're only actually executing this this branch of code throughout the rest if it's false. So what I'm doing is if was on is whatever the output was the last time it came through. So for instance, if our output was on last time and it's being turned on again, we don't need to do anything because our gate state isn't actually changing. Whereas if we were off before and now we get turned on, meaning that was on, so in the last iteration we were off, so was on would be false, then we're turning it to on. I hope I was clear enough with that. If not, write me in the comments and I'll try to talk about it a little more. So then, just like we did with the inputs, we change the material depending on if it was on or off. And then we move into changing everything that it affects. So if we read the comment right here, it says it will change all the output connectors, and I kind of use connectors and wires interchangeably, so just bear with me. So it changes all of the connectors it is connected to. By default, I only really want this to be one connector, but in case I need more, I went ahead and made an array. So we're passing this array into a for each loop, which then checks if the mesh that it's referencing is actually a valid mesh. And then depending on that, it will either turn on or turn off the connector depending on whatever our output evaluated to. And then we do pretty much the same thing with gates, where I have all of the gates that this current gate is connected to. I pass that into a for each loop, and then this gets passed into a branch. And so this is that input for gates that I was talking about. It's true if it's for input 1, false if it's for input 2. So if we follow this right here, so we have our output gates right here. We push it into the for each loop. And then as we're cycling through this loop, we have for each element in that output gates, we have an equivalent or a corresponding element within output gates. So that's right here, we're taking the array index and we're passing it into this get method. So that all we're doing is just getting the Boolean expression or the Boolean value that is in that place within this array. And then depending on if that condition is true or false depends on if we are modifying input 1 or input 2. And so like if we're turning off the inputs, then we go down here and we're either turning off input 1 or turning off input 2. So this is pretty much all of the programming that goes into the gates. Ooh, I forgot to mention, this gate test right here, we go and look at that. It looks kind of weird. There's really not much going on in this parent class. We're actually passing it the first input back as output, which seems kind of stupid, and is. But if we read the comment, we realize this function will be overridden in the child classes. So let's go back to the child class for AND gate. So once again, this event graph is completely empty, but if we go to this gate test function, we see it's getting past the execution line in the gate test, and then it actually runs the AND Boolean function on each of these inputs. And so this is all of the programming we need for each of the gates. This is kind of the beauty of the system of using the gate parent and then inheriting off of it, is each gate itself only needs this little line of code, and it is a completely different system. So for instance, if I go to the NAND gate, we see it's actually almost the exact same thing, just instead of an AND Boolean function here, we have a NAND. So let me go back to gate parents. So this right here is basically just specifying how these gates work together and how they connect with wires. And then the gate test function just says how our output should be. So we have one other piece to this, and that is the wire, which I have right here. And this is programmed very similarly to how I did the gate parent. So if we look right here, we have two custom events, kind of like the gates. We're either turning on the connector or turning off the connector. Once again, we have this was on Boolean that will tell us whether or not our output or this connector has actually changed value. Because if it hasn't changed value, we really don't need to push it ahead and try to change everything that it's connected to, because there won't be any change from the previous cycle. So once again, we set our Booleans just to see, or we set our was on to hold where it was. Then we set our material to either on or off depending on which branch we were or which branch we're on. And then from here on out, it's almost the exact same as the gate parent. We're changing all of the connected gates, which once again, we have the connected gates. We have the connected gates Boolean input, which once again just says if it's changing input 1 or input 2. And then we connect all of the wires that this wire is connected to. So, like I said, basically the same as gate parent. One thing I should mention, and this does make me a little nervous, I had to play around with the ordering of whether I should turn on the gates or the connectors first. So one of the issues that's come up with this project is in real life when you have electricity, it's almost instantaneous in how fast it gets to places, and so it kind of floods the circuit all at once. Whereas with programming it in Unreal, it really only can run sequentially like most other programs. And so I have to kind of take that into account. Now for most circuits this isn't really a problem, but if we look at this bit circuit right down here, we see that it has a feedback loop where the output of one is the input of another, and this can cause some problems with infinite looping if we're not careful. And so that's why I had to play around with what order the turning on the wires or the gates was. And so for right now it seems to work. And in the next video I will go over how this circuit works, and then in the next one I'll go over this circuit as well. So those will be the next two videos. I think I've covered pretty much everything as to how I actually went about programming these things to function. And hopefully now that I've programmed how they interact with each other and how they evaluate to the correct output, I should just have to connect the gates up in the correct order and connect the wires, and everything should be good to go. Well, I hope this was interesting and informative, and I hope to see you next time. Thanks. Bye.